Well, the next thing we want to consider in our two-dimensional equilibrium series here is couples. And couples don't get analyzed very often, but when you see them and can recognize them, it can make your problems a little bit easier. But let's say that we have this, this is kind of like a subway car or a commuter train, something that is kind of cantilevered out here to the right-hand side. And it has a weight, and I think the textbook says that mg is 24,000 newtons. I forgot to write that down. We want to find the contact surfaces at these 3 points of contact, which are kind of holding it out there. So if you can look carefully, there's a contact surface here. So in other words, this is trying to keep it from moving down this way. It wants to rotate this way, so that means there's a contact surface right there. And as it does that, there's another contact point right there. So let me go ahead and draw all of those forces in here. I'll say that there's going to be a B right there and an A. I'm going to put it like that, a little ways away. And I'm going to put C in like that, and I hope that's easy to see, something like that. All right, how can we analyze those forces? Well, these are equal and opposite and not collinear. The reason I know that is because they're only force going in the vertical direction, therefore they have to be a couple. Because this is a couple here, that means this also has to be a couple because these are also opposite and parallel, so I can know by observation that they are also equal in magnitude. So all I have to do is just say that sum of the forces in the y is equal to 0, so I'm going to say that B is equal to 24,000. And so the moment due to that couple is equal to 24,000 times 5. And that's going to be the same magnitude of the couple as A and C. And so that's also going to be equal to A or C times 4. In other words, that's also the moment of the couple. I'll call that AC, and we'll call this the moment of we'll call this couple BG. We'll call this BG. Moment of the couple BG has to be equal to the moment of the couple AC. Therefore, I can find A is equal to C is equal to 100 and let's see, what is that? 30,000. These are going to be 30,000 newtons. Come on, 30,000. And whenever you have two couples, what do you call two couples? That's a double date. So you may see or hear me in tongue-in-cheek referring to, if I see two sets of couples, I may call that a double date. All right, let's well, this one here is similar, and this one has a weight that is coming down. This one actually is a pin and roller kind of thing, and maybe you can see it, maybe you can't, but I'm going to say that this is going to be the pin. Actually, let me draw this separate free body diagram. That's probably easiest. I'll just say that there's the weight. This is going to be the pin, and it will have something trying to pull back there, and this one will be the roller. So you can see, pretty obvious that this is a double date as well, and the only way for this to work is for this to be the roller down here. If this was a roller here, if this was the pin here and this was a roller, it would just fall off. So the only way for something like this to work is for this one to be a pin and the roller to be down here. All right, let's see if we can find out the magnitudes of everything. It says mg here is equal to 500 pounds. So sum of the forces in the y is equal to 0. So AY is also equal to 500 pounds. And the moment due to AG is equal to 500 times 1.5, which is also equal to the moment from AB. So that's equal, and that's separated, that's A times 3. So I can say A is equal to B, AX is equal to BX, and that's going to be equal to 250 pounds. So anyway, that's just a quick and easy, dirty way of looking at couples, and sometimes your problems can be simplified looking at that. All right, the next thing is a FBD, free body diagram practice kind of thing. So there are 2 pages here. If you have printed them, then you should work on those 2 pages for as long as it takes. When I've done this exercise in class, it may take 15-20 minutes, depending on how many people are working together and what that is. But you can pause it for as long as you feel that you're comfortable for. And then after, this is the next 2 pages, and then afterward, well, I'll show you the solutions. Okay, so here are the solutions to those 2 pages. I'm not going to go through them with you, but you should look carefully at the reasons why these are like they are, what I've given them here, and if you have any questions, you should bring it up in a happy hour or email me. So this is page 1 and this is page 2. Again, those are printed in your student notes, so you should have them for your reference.